We're still with critical thinking, and our topic now is using inductive reasoning. But before we get into it, we'd like to have a recap of what we discussed earlier. We look at some definitions of critical thinking, and we saw that critical thinking is a very conscious thing we do. It involves the intellect, scrutiny, examination of things, asking questions, finding solutions, and solving problems. So it's a very practical thing. And of course, at the end of the day, it becomes even part of a person's attitude. It is easy to tell a critical thinker from one who is not. We also came to see the difference between opinion and fact. We saw that fact can be proved either by definition and also by observation, or definition or observation. And we saw that opinions cannot be proved. We saw that fact can be evaluated by information which is up to date, consistent with other known facts, as well as from a reliable and unbiased source. Opinions, on the other hand, are also evaluated. If opinions are supported by facts, then they are sound. If they are not supported by facts, they are unsound opinions. So even though facts are solid and are reliable, opinions are not reliable. But opinions are not completely useless, because we can get opinions and still make good conclusions on them. So we saw the difference between opinion and fact. We are now moving on to using inductive reasoning, and it's also called induction or inductive reasoning. It is one of the most basic type of reasoning, which means that all of us, children, adults, people of all kinds, engage in everyday inductive reasoning. We may not be aware that we are using inductive reasoning, but we definitely do. And our knowledge of it from today onward would help us to become more conscious in our inductive way of reasoning. So we want to get right into it. So it's one of the most basic types of reasoning. Is also called induction or inductive reasoning. So when you hear of induction, it's the same as inductive reasoning. What is it? Inductive reasoning. It is the process of arriving at a general conclusion based on specific facts. Take note, it's a process. And you arrive at a general conclusion on a foundation of specific facts. So facts have come into play again. In order to engage in inductive reasonings, facts come into play. You gather facts together, and then from the facts, you go on to a general conclusion for yourself. So let's look at some of the ways that this is done. So we saw earlier that observation is key when it comes to critical thinking. So right over here, the way to reason inductively, observation plays a key role. So you observe specific facts. You observe specific facts. So observation is important. You meet somebody for the first time, and the person happens to be very rude towards you. Of course, people say that first impressions don't really matter. Well, so you don't mind. You meet the person another time, the person is rude. A third time, rude. A fourth time, rude. On and on and on and on. What are you going to begin to think? Maybe this person is just rude. Inductive reasoning. So you observe specific facts, noticing specific patterns or similarities. You draw a conclusion. So the conclusion we form about people, about things, about concepts, all of them can be done inductively by observation, and then you notice specific facts. So you note somebody, and then you hear the person's voice. You meet the person's younger brother, younger sister, children, and you notice some particular type of voice. And you could ask, do you belong to the Johnsons? Why do you ask? Because you're noticing some similarities in the voices you hear. So you're drawing a conclusion that this type of voice could belong to the Johnsons. So you observe specific facts, you notice specific patterns, similarities, which all call for observation. And then you draw a conclusion. Do we do that all the times? Oh yes, we do that. So our whole life, every day, is full of inductive reasoning. You meet people, you see things, you draw a conclusion. Now the conclusion from inductive reasoning is called generalization. Generalization. So take note, observation is a key factor. Noticing patterns or similarities, another key factor. And then you draw a conclusion, key. The conclusion you draw from inductive reasoning is called generalization. So you are generalizing. The conclusion from inductive reasoning is called generalization. Now, the group of specific facts on which the generalization is based is called a sample. So you can see that this is simply taking us to research. And when you want to find out about something, you collect data. And then what you call, or you look upon your population or people or a group of things, and you select a few. And then from the few, which is the sample, you can draw a conclusion called generalization. You can think of it if you prepare your soup or your stew, and you put salt in it, and you want to be sure about the seasoning, whether the salt is okay. What do? Do you drink the entire soup? Or you eat the entire stew? No, you just take a sample from it with your ladle. And then, you taste it, so yeah, the salt is okay. If the salt is not okay, you can tell from that small portion of the stew or the soup you fetched. Sample. By the same token, when you gather specific facts, and then you draw the conclusion, which is generalization, the facts on which you draw your conclusion become your sample. Of course, we haven't talked about your conclusion being a fact or true or false. It could be true, it could be false. Because not every sample will be able to accurately represent the entire group, while some samples can. It all depends upon the way you do the sampling or the way you gather your facts and the particular type of facts you gather. All of these are important. Or what you may be interpreting to be fact may be something else, which calls for a lot of consciousness, a lot of awareness in the thinking process. So, once again, you observe specific facts, you notice specific patterns, similarities, and then you can draw your conclusion on that. The conclusion is drawn is called generalization, and the group on which you draw your conclusion is called sample. So we've seen sample, we've seen generalization. Now we can move on. So we saw that generalization is your conclusion, but for every thinking process, as we saw earlier, involves a lot of balancing of things, intellectual balancing, scrutinizing, analyzing, evaluating. All these things come in place. So you may generalize But at the same time, you have to be careful that your conclusion, your generalization is exactly the reality, not more, not less. That calls for a lot of balancing, doesn't it? So, one of the things that we need to avoid, is what we call overgeneralization. Overgeneralization. If you overgeneralize something, it's already even self-explanatory. It is more than reality. It is more than that. For example, if you talk about overeating, then it means you eat more than necessary. Over drinking, you drink more than necessary. Anytime we see the over before the verb, is more than usual or more than normal. So, if we say overgeneralization, we mean that you're doing more than it should be. So, any type of reasoning is as good as the fact on which it is based. That's a very important point all of us need to take note of. Any type of reasoning is as good as the fact on which it is based. So, your conclusion, your reasoning, the quality of it or otherwise, all depends upon the facts on which it is based. Now, let's imagine this. You have 10 oranges. 9 sound very good, juicy oranges. 1 rotten orange. If you squeeze all these oranges, the 9 sound ones, as well as the 1 rotten one, into a jug, would you be willing to drink that juice? No. Mathematically speaking, you could say that the orange juice is 90% sound. And if you put that in the grading system of the universities in this country, that is an A. Excellent. But you would not drink that juice because out of the 10 oranges, 1 is rotten. So it will make the juice unwholesome. Now reduce the 10 oranges to 5, all sound, none rotten, and you squeeze these oranges. Would you drink the juice? No doubt about it, you will drink it because it is wholesome. So take note that any type of reasoning is as good as the fact on which it is based. That means that to be able to arrive at a reliable conclusion, every single fact that we collect together to form part of our sample on which we draw the conclusion must be sound. Any of them that is rotten, metaphorically speaking, like the orange, will make the entire reasoning very poor and our conclusions not reliable. So take note of the orange illustration. So make sure that every single fact you collect is actually a fact, or else your conclusion will be unacceptable or will be wrong and even disastrous. Remember that when it comes to building and architects work on a building and they use shoddy materials and the work is done haphazardly or anyhow, what happens? That building will collapse, no matter how big or small it is. But if the architects or artisans take time and buy quality material and do the work very well, the building lasts. It is the same with reasoning. The things on which you base your conclusion, the facts, if they are solid, your conclusions will be solid, and if you use those conclusions to solve problems, you'll be successful. On the other hand, shoddy thinking, as we saw earlier, is disastrous and even costly. So that you have to be sure that the facts that you have are really facts. not opinions in the garment of facts. So, what is overgeneralization? That's our question. Overgeneralization results from samples that are too narrow and unrepresentative. Samples that are too narrow and unrepresentative. There's a very sober thing for us to think about. If we overgeneralize, it comes from samples that are too narrow and unrepresentative. So that is why, for example, maybe you have bought 2 items from China, or you bought just an item from a shop, and the item turns out to be of low quality, and then you don't like it. And then a colleague asks you that, what do you think of that shop, their products? And you say that no, they sell very inferior goods. 1 item or 2 items. Isn't that too narrow or too unrepresentative a sample on which to base your conclusion? Obviously. You just bought 1 item. But do you realize that our lives are full of many, many overgeneralizations? So remember the sample. Is it too narrow? You've bought 2 items from China, and then it happens that it doesn't work so well. People say Chinese goods are inferior. But if you ask them the number of items they've bought from China, it could be just 1, 2, or 3. But there are many things from China. So, this example about China and about a shop is simply to illustrate overgeneralization. That if we conclude on a very narrow sample or a very unrepresentative sample, then we will be overgeneralizing. Suppose somebody comes to UNE and picks 2 students, and they turn out to be very brilliant, and he says every student in UNE is brilliant. I mean, that's beautiful. But even though that is a positive conclusion on behalf of UNE, would that be representative? Because there's not a single school on earth where every student is A. None. By the same fashion, if somebody picks 2 students from UNE and they don't perform so well, the person says that, oh, UNE students are just not good. Still overgeneralization. So it means that in our reasoning, we have to be conscious. We have to be sure that the sample is big enough to represent, so that if we conclude, we can say that our conclusion would be reliable. Now I want to see how we can avoid overgeneralization. Remember that generalization itself is based on sample big enough and representative enough. But if we overgeneralize, then the sample becomes too narrow and unrepresentative. So we want to be sure that we avoid this danger in critical thinking, because it causes a whole lot of havoc for the one doing the thinking and against other people or things. And you may be surprised to know that a lot of history has shown that people engage in shoddy thinking end up being very destructive, and they find out later that they've made a lot of mistakes because of overgeneralization. We're going to look at some very almost controversial types of overgeneralizations for the sake of this course, so that we know that we are thinking people. We want to understand things the way they are exactly on the ground, and so that we would be thinking people, say facts, and of course show respect for people and things without hurting anybody, but address the bare fact because we want to be critical thinkers. So we want to see how we can avoid overgeneralization. How to avoid overgeneralization? Now keep samples as large and as representative as possible. Keep samples as large and as representative as possible. Do you know that, for example, that you might have known somebody when you were a child and then he was stealing? And you've lost contact with the person for more than 20 years and you've met the person once again. Somebody could ask, what do you know about this person? You may be tempted to recall what you knew about the person from the past. And you may end up that he is a thief. Most of us fall victim to such thinking. But how much information have you had on that individual for the past 20 years? Hasn't he or she changed? That is possible, isn't it? So, what we're saying is that you want to keep your sample of information as large, not just being large, but also representative. Because there is a possibility of your sample being very large, but not representative. It's just like when you want to collect the clothes that someone wears, and he only gathers hundreds and hundreds of his trousers without any top, any shirts. Even though you have a lot of trousers of the person, that is unrepresentative of the person's clothes because he wears not just trousers, but other things. So we are not focusing only on size. No. We are focusing on size and we are also focusing on representativeness. Thus, the sample represents what is there. So, UNED, for example, comprises students. We have diploma students, we have degree students, we have master students, and we have students pursuing PhD. We have males and we have females. So if anybody wants to get information on UNED students in its entirety, and only picks 100, level 100 students, that's quite a number. 100 is big. But would 100 students be representative of the entire student population of UNED? Obviously no. So big, but not representative. It will involve levels 100, 200, 300, 400, 500, 600, whatever the case. It will involve males and females. You can go further into different courses. It will involve a lot. And there must be samples drawn from all of these categories so that the sample will be large enough and at the same time representative. Once that happens successfully, we avoid overgeneralization. So you keep samples as large and as representative as possible. And then you want to never make a statement about an entire group unless the statement is absolutely true in the case of each member of the group. Never make a statement about an entire group unless the statement is absolutely true in the case of each member of the group. So that's one very key point that we would definitely want to address, which is very important. Now let's take this point very well. It says, never make a statement about an entire group unless the statement is absolutely true in the case of each member of the group. Remember, this could be about things or about persons or humans. Because there's it's a critical thinking class where we want to address things openly, but of course respectfully. I would like to give some examples that would help us to become open-minded and also to see things in realistic terms. And then we would understand it. Now, if we are able to overcome this, that we only make a statement unless the statement is true of all the members of the group, we'll be very careful. Now, one of the overgeneralization that we'll come to see ahead is stereotyping. I don't want to get into that right now, but we would come to see it ahead, and then we'll come to this point. So take note of this point. Do not say anything about any group of things or group of persons unless what you say about them is absolutely, entirely true as regards every member of that group. A very powerful point for critical thinkers to hold on to. And then use qualifying words to limit the scope of your generalization. You use qualifying words, maybe the ones you have seen, the ones you have heard, the ones you have worked with, so that it wouldn't be about those or that you come in contact with. That is what you're referring to, not the entire group of the things or the persons. So let's look at just some of those qualifying words, and then we can close the chapter on this section. You can close the chapter on this section. So use qualifying words to limit generalization. If it is what you're talking about is absolute, then we can say all, or every, each, none, never, always. Now, the moment you see these words, I believe that you're already realizing that there are some things we say that we ourselves come to see that, whoa, then we are overgeneralizing. Don't we tell people you would never come to work early? You are always late. But is that true for someone to never be able to come to work early? You know, you see that. You could ask a question, somebody, oh, he doesn't know anything, we say that. Is it possible for a human on earth not to know anything? Even his or her name? I mean, that's impossible. So, all, every, each, none, never, always. If we believe that what we're talking about is absolute in the case of each member of the group about which we talk, then we can use them. On the other hand, if we are not sure and we are only describing or talking about, concluding regarding just a sample that we have come in contact with, then we can use some. We can use few or a few, occasionally, sometimes, hardly, little, you know, we can use, these are just some other words that we can, qualifying words we can use to show that something is absolute or not absolute. But we want to use qualifying words to limit our generalization so that we do not fall victim to wrong thinking. What have we done so far today? We've come to see what induction is. What induction is. We know that is a basic type of reasoning. You arrive at a general conclusion based on specific facts. And then we saw that you observe. Observation plays a key. You also notice patterns or similarities. And then your conclusion is called generalization. And then the fact on which you base the conclusion called a sample. But we must be careful not to fall victim to what is called overgeneralization. And because our reasoning is good based on the specific fact that on which we build a conclusion. And We fall victim to this overgeneralization if our sample is too narrow and unrepresentative. We came to see how we can avoid that. So we keep samples as large and as representative as possible, and then we never make statement about an entire group unless we are sure that what we say is true in the case of everyone or everything in that group. And then we use qualifying words. If it is absolute, we use words in this category. If it is partial, we use words in that. If you're able to do that successfully, we will be on a good journey towards becoming critical thinkers and would enjoy our lives. Thank you. That's the end of this section.